Hi, hello. I'm Judy. I'm an engineer at Duolingo, and I'm excited to share about Rive today. Duolingo is the world's most downloaded education app. Duolingo's mission is to develop the best education in the world and make it universally available. So Duolingo teaches more than 40 languages across more than 100 courses. We've expanded to new subjects and launched math and music on iOS in the past couple years. Some of you today may already be in those courses on your Android device. The apps are known to feel like a game, but you're actually learning. To make learning fun and immersive, we use animation and motion design to amplify the game mechanics and even serve as game-like learning features. So what are we using to build many of our animations that we use across iOS, Android, and web? Introducing Rive. Rive is a web-based tool for making real-time interactive animations and designs. A little peek at what the editor looks like. So animators, designers, or developers can use a collaborative editor to create motion graphics that respond to different states and user inputs. This particular animation has correct and incorrect states to indicate changes to the animation based on whether or not a user correctly answered a question. So Rive State Machine is a visual representation of the logic that connects the animation's states together. Developers can programmatically control which animation states are called, how they are called, and how they transition and come together. The several speaking states here can be blended to accurately reflect endless combinations of spoken sentences in the app. And you can learn more about the visual states and the sound mapping on a Duolingo blog. The Rive file format is built specifically to run in real time. It's quite lightweight, taking up only a fraction of the size of videos, GIFs, image sequences, and even JSON-based formats like Lottie. We'll get back to this later. Now, Rive can run anywhere. At Duolingo, we use the first 4 platforms here. Our friends at FlutterCon may be using Rive too, but don't worry. I'm at the right place. We're focused on Android this afternoon. Now, why are we thinking about Rive for features? There are several reasons, and the ability to use Rive cross-platform is huge. We can reduce complexity for engineering on building animations. Oftentimes, animations can be cut from scope because they usually add delight and not core functionality, but that's not the case with interactive features. Stick around to see what feature-driven UI component iOS natively built with over 1,000 lines of code for logic. We hope Android can simplify this by just plugging in a Rive animation and going from there. So natively built UI often leads to platform discrepancies. Some UI can be easier or harder to build on different platforms. And different bugs can be introduced. But with one Rive animation, we not only guarantee all visual states are the same, but we also guarantee all behavior is the same. So this illustration is what we use at Duolingo for our operating principle on striving for excellence. And I do believe visual and behavioral consistency is excellent. This last point ties back to the others. When we can save engineering time and create consistency and correctness, we can also hopefully ship it all faster. This is also considering our animators' time as well. Now let's take a look at some examples of where Rive is used at Duolingo. In this feature, characters host a radio show. It's called Duo Radio. You can see the different states a character can be in. Here's how it looks with characters speaking and sitting at a desk. I think from the animator's perspective, Rive is fast because they can animate once, like where the character raises the volume and taps on the mic, and they just use that for switching between characters. The learning paths for math and music also use Rive. These animations are predefined and they just kind of loop over and over again. So this isn't a situation where like Rive necessarily shines, but it goes to show that Rive can perform for your most basic needs. Now let's look at where Rive does really shine, and that's with some interactive examples. So our avatar builder uses Rive. I can tap on any option here. These are buttons that contain a Rive animation set to a certain hairstyle. I can change the state of the large Rive animation, and that's my avatar. We also have adventures where characters are in a scene and go through a situation in the user's learning language. This is just one episode at the doctor's office, and it's made up of a background and several props. As you can see, a user interacts with these props and characters, which are actually individual Rive animations, and tapping around the scene is also how the user walks.
Yes.
So I work on the math team, and we can walk through how we can implement a feature using Rive. So our job right now is to build a screen with an exercise called the fraction fill, where a user is asked to select parts of a fraction pi to indicate their answer. So 1/5 plus 1/5 equals 2 pieces selected, for example. Got some requirements, supporting 2 to 8 as a denominator or total fraction pi parts. If we want to support light and dark mode, we want to support haptics. They should fire whenever a piece is selected. We need colors to change depending on whether or not the user got the answer correct. We also want to enable or disable the check green button, so the user can only attempt to submit if they have something selected. Our animation file that's been handed off to us has been built to support most of this. So now it's coding time. Off screen, let's assume we started by following the Android Quick Start Guide that Rive has. We'll add their open source library to Gradle, and we'll initialize Rive. We'll do a traditional view implementation first. A couple of reasons for this. We are often working in legacy code bases. Our views are relevant, and usage for compose ties back to how we'll use views.
Right.
So starting with Rive's custom view, we'll call it Rive input in our XML. Then in our fragment, we'll fill the view with our Rive animation by calling set Rive resource. Before I say more, I want to mention this code is not like an opinion on how to architect your Rive usage. It's more of a demonstration of the API usage, and I've modified code for presentation readability. All right, so what's going on here? We have our Rive asset, which is a .rive file type in raw resources. It's going to be up to the devs and designers to figure out like how the Rive asset is best built. Here we have a separate file for 6, 7s, 8s, but it doesn't have to be that way. One file can definitely represent all of those. So these string names are built into the Rive animation. Yeah, so these string names are built into the Rive animation. So our animator may call the artboard a pie chart while they're building the asset. So we'll use that same string. Again, maybe these aren't hard-coded on the client. In practice, maybe backend is providing these strings, but you can see what it might look like just from the snippet. Now, on to setting a state for setting light versus dark mode colors. Our asset was built with a Boolean for toggling light and dark mode. So we'll set the Boolean value for the right input in the animation state machine. Our incredible animators have handed off this asset with exact specs on what input strings we call. So the value here now is pretty straightforward. It's just going to figure out like whether or not the user is on light or dark mode, and it'll pass that in. For our next requirement, on changing colors for grading. We set a number state this time. So our animation spec defines colors as a number state. 1 means green, 0 is blue, which is default, and then 2 is going to be red, but we won't use that today. Lastly, we want to respond or react to events that fire from user interaction, so we set up an event listener. Our animation fires a haptic event to indicate when we should trigger a haptic feedback. It also fires an up event to indicate a user lifted their touch up and selection is complete for us to figure out how many parts were selected. Let's take a look at on state change once that event fires. So depending on how your animation file is built, maybe each fraction piece has a Boolean that indicates whether or not a piece was selected. Here we are counting up how many pieces were selected, or rather like active, to report what the user's answer is so far. The Booleans read are SMI Booleans, SMI meaning state machine input, and this is one way we know how to access them. Or maybe the Rive animation already supports how many pieces are selected through a single field. Alternatively, this active count could be within an SMI number. So cool. With that, we're pretty set with our requirements for the traditional view implementation. Let's think about compose. So Huckleberry, a user over here, opened an issue on the Rive Android repo on declarative UI support. Rive already has support for Swift UI. Can we get support for Compose UI? Today, this ticket is still open, and the Rive library does not have official Compose support yet, but that does not mean we're doomed. Rive gives us a sample on how we can use Compose. So the snippet is directly from their Android repo. Now wrapping a Rive animation custom view within an Android view is a viable workaround. Using an Android view interop maybe is not an ideal choice when working with legacy views, but when the view might be complex to rewrite in Compose, we can go with something like an Android view. Notice how familiar the code is looking now. We're setting the Rive animation the same way we did with views. But what if we, need to respond to updates on the composable? So here's like a modified version of what we can do. We add a function param that gets invoked on update. And on update can look something like this, with parameters related to setting input states. We could also include our listener here. And then things look very similar again for setting light versus dark mode, or setting correctness colors. Putting that all together, we built our feature. But before we do that, maybe sandboxing could be helpful, because unfortunately, we don't have composed previews working, let alone interactive composed previews working. So we can build a non-production fraction fill screen as our sandbox. We actually did build this full composed screen at Duolingo, and it helped us verify different inputs without needing our devices to be in actual light or dark mode, without needing any logic around grading whether the answer is correct. It's a quick way to validate the state machine works through a couple convenient buttons. And we can also verify that outputs work as well. So notice here, our sandbox reports how many pieces are selected, is selected 0 out of 8, 2 out of 8, etc. While I'm interacting with the asset. Now I have the 8ths animation plugged in, but I could easily swap out for thirds or something else to test out. And lastly, we might be seeing issues with what we tried to verify. So that could mean iterating with our animators to figure out different solutions. Cool, we're done with Android. What about iOS? So they have their own guide for setting up, and I'll link that at the end too. But the implementation would look something similar, with setting the animation and setting different states. And then together we'd have consistent interactive UI across platforms. And in fact, iOS and Android are both using Rive for fraction fill today. So what's next? You may remember earlier that iOS natively built a UI component that was over 1,000 lines. That is this clock for teaching time to learners. I don't have a roadmap here, but if or when we port this to Android, we hope not to write 1,000 lines of difficult UI code and can just plug in this Rive asset, and maybe iOS could migrate too. So you're seeing a preview of a web demo where I'm toggling and changing different inputs, and I'm directly interacting with the animation too by moving the minute and the hour hand. Another cool component that is difficult to build natively would be this measuring cup. I honestly don't know the physics of water movement, and sharing this Rive component with iOS means they also wouldn't need to know either and can rely on the animation consistency that Rive gives us. Now let's be mindful about a couple things. You may be wondering about performance. Specifically, how might Rive compare to Lottie? This is a Slack message from an early adopter at Duolingo. They mentioned file size here went down 15x when going from JSON format to a Rive format. Because Rive animations are built to run in real time, they tend to be smaller, and that's great. Now, one question I got yesterday is whether Rive was a competitor to Lottie, and I'll mention that Rive can do what Lottie can do. So it's an alternative, but it can also do even more. So depending on your needs, if your app wants interactive animation features, Rive is a wonderful option for you. The technology is pretty nascent. Community is also pretty new, but it's not small. They're filling a gap with what Lottie doesn't cover. And it's not that Duolingo replaced Lottie with Rive. We actually still use both. Another consideration is whether a device can initialize the Rive library at all. We found that only a very small portion of users fail to initialize Rive, and that's 0.02%. For those users, and perhaps users in like a power saving mode, or maybe in some other condition where you think it might not be right to animate for them, we can show static fallbacks. We'd want to fall back to like a regular vector, and of course this doesn't work for some features where animations are more of a requirement and not just supplemental. So in those cases, we may want to hide the feature from users or disallow static fallbacks. So we hear animations are small, like these files are pretty small, but what if we need like hundreds of them or even more? The combined size can add up for our app size, and we could instead remotely load Rive assets. These files don't have to live on the client, and a lot of them in our app certainly don't. Lastly, I'll share that animators and developers can think of ways to make their components accessible. In our sandbox, we tested whether a user could select a piece by changing the input value directly. So tapping the test accessibility button in the sandbox selects one piece, and success here means we can support tough mode. In summary, you can try Rive for predefined, procedural, or interactive animations on any platform. But yeah, consider it for Android. Duolingo found success with Rive, and you might as well.